There's a school of thought that claims Earth is flat, an old idea dressed up as a new rebellion. Ancient cultures once imagined the world as a giant disk floating in the void, but they didn't have telescopes, satellites, or even the chance to sail across oceans. Today we do. We've crossed the seas, mapped the skies, and sent machines into orbit. Yet somehow the flat Earth myth refuses to die. The flat Earth theory isn't just outdated, it crumbles under gravity, physics, and common sense. And here are 5 reasons why. Gravity. Gravity is the quiet architect of our universe, shaping galaxies, binding planets, and keeping our feet firmly on the ground. On a spherical Earth, the logic is elegant. Gravity pulls everything toward the planet's center of mass. No matter where you stand, whether in Lagos, Tokyo, or Buenos Aires, down always means toward the core. This symmetry is what allows our oceans to stay level, our rivers to flow logically, and our buildings to rise perfectly vertical. But on a flat Earth, this balance unravels. Gravity would not act uniformly. Instead, it would tilt and distort in ways that simply don't match our lived reality. Imagine the supposed disk of a flat Earth. At the very center, gravity might behave somewhat normally, pulling directly downward. But the farther you move away from that center, the stranger things would become. Gravity would pull diagonally toward the middle of the disk. To someone standing near the edges, down would no longer be beneath their feet, but at an angle pointing inward. Everyday walking would feel increasingly skewed. Near the rim, people would feel like they were leaning perpetually toward the center just to remain upright. This isn't a minor quirk. It would completely reshape how humans, animals, and even ecosystems could function. Rivers, for instance, owe their predictable flow to the consistency of gravity. On a round Earth, water always travels downhill toward lower altitudes, guided by the uniform pull toward the core. On a flat Earth, rivers near the outer regions would defy intuition. They would curve inward, flowing not toward nearby basins, but diagonally across the landscape, all seeking the central point. This would create rivers that appear to run uphill or twist unnaturally, and oceans that accumulate toward the middle like liquid pooling in a shallow dish. The coastlines we know today would not exist. Cities like Sydney, Cape Town, or Buenos Aires, situated thousands of kilometers from the supposed center, would be dry wastelands. The oceans, too, would behave very differently. Water is unforgiving. It always obeys gravity. On a disc-shaped Earth, the seas would slide toward the middle, forming a swollen bulge of water there while the edges dried out. Instead of the broad, balanced oceans we know today, we would see an immense central sea surrounded by barren lands. Coastal trade, global exploration, and even the idea of seashores, as we know them, would be impossible. Yet every coastline, from West Africa to the Pacific Islands, demonstrates that water spreads evenly across the globe. The deeper one looks, the more contradictions appear. If Earth were flat, gravity would warp every element of daily life. Water would not stay level, rivers would not flow predictably, and buildings would not stand straight. Even basic human balance would be disrupted by the constant inward pull toward the disk center. None of this is what we observe. Instead, we find gravity acting consistently in every corner of the world. This consistency is the hallmark of a spherical planet. A globe explains why oceans rack smoothly around Earth, why rivers follow geography rather than imaginary centers, and why skyscrapers stand upright in every city. It is a model that matches both theory and observation, from the simplest pendulum to the most advanced satellite. Flat Earth ideas stumble the moment gravity enters the conversation. A disk cannot hold water evenly, cannot support balanced structures, and cannot explain why down feels the same in every place we've measured. Gravity is not just a force that holds us in place. It is evidence written into the very shape of our world, and it tells us unequivocally that the Earth is round. Day and night. The daily rhythm of sunrise and sunset is one of the most dependable experiences on Earth. It is also one of the strongest demonstrations of our planet's roundness. On a spherical Earth, the explanation is straightforward. As the planet rotates on its axis, different parts face the sun or turn away from it, creating day and night. But in a flat Earth model, this elegant system falls apart. The sun would have to behave very differently, like a spotlight circling above the disk. And that's where the contradictions begin. A spotlight sun might sound simple at first. Picture a lamp moving in a circle above a flat stage, shining only on part of it at a time. This is how flat Earth theory tries to account for day and night. But the model doesn't stand up to scrutiny. If the sun were simply circling overhead, it would never truly set. Instead, it would just appear smaller as it moved farther away, always hovering above the horizon like a dim streetlight. In reality, the sun doesn't fade into the distance. It disappears completely, dropping cleanly below the horizon line. The sharpness of a sunset is only possible on a curved surface. The problem gets even worse when we consider seasons. On a globe, seasons occur because Earth is tilted on its axis as it orbits the sun, causing different hemispheres to receive more direct sunlight at different times of the year. This explains why it's summer in Australia when it's winter in Europe, and why the tropics are consistently warm. A flat Earth model, however, has to twist itself into knots to explain seasons. It suggests that the sun spirals in and out, circling closer to the center in summer and farther out in winter. But this doesn't match observed reality. The changes in daylight length, the shifting of the sun's height in the sky, and the predictable timing of solstices and equinoxes all collapse under the flat model. Then there's the polar regions. In Antarctica, the sun can remain above the horizon for months at a time, circling continuously in the sky during the austral summer. In the Arctic, the same happens during the northern summer. On a flat Earth, this should be impossible. The spotlight sun should leave vast portions of the disk in darkness. Instead, both poles experience their own midnight suns, perfectly explained by Earth's axial tilt on a spherical orbit. These are not abstract theories. They are direct observations made by explorers, scientists, and even tourists who travel to polar regions. When you connect the pieces, the picture is clear. The way the sun rises and sets, the way shadows stretch across the globe, the rhythm of the seasons, and the strange but beautiful midnight suns at the poles. All of these phenomena are consistent only with a spherical Earth. A flat Earth cannot replicate them without inventing elaborate, inconsistent mechanisms that still fail to explain what we actually see. The joy of science lies in how neatly reality aligns with the right explanation. The globe model of Earth does not just predict day and night. It accounts for every variation, from equatorial heat to polar night. The flat Earth model, by contrast, crumbles under its own contradictions. Day and night are more than just the turning of time. They are proof, every single day, that our world is round. The edge problem. If Earth were flat, one of the first questions we would have to answer is, where does it end? A disk, after all, must have an edge. Flat Earth models often propose that this edge is surrounded by a vast ice wall. Antarctica, reimagined as a frozen boundary holding in the oceans like the rim of a giant bowl. At first glance, this may sound dramatic, even cinematic, but once we look closer, the idea of an edge becomes one of the weakest points of the flat Earth argument. Start with geography. Antarctica is not an ice wall surrounding the Earth. It is a continent at the southern pole, mapped extensively by explorers, satellites, and aircraft. Its size, shape, and features are documented in detail, from the towering mountains of the Transantarctic Range to the massive Ross Ice Shelf. People have circumnavigated Antarctica, flying and sailing around it. Something impossible if it were instead an endless barrier stretching around the world's rim. You can't fly around a wall. You can only fly past a coastline on a continent. Then there's the question of what lies beyond the supposed ice wall. Flat Earth proponents usually leave this part vague, sometimes suggesting more land, sometimes infinite void, sometimes nothing at all. But physics is unforgiving. If Earth truly were a flat disk floating in space, it would not remain flat for long. Gravity would pull matter toward the center, collapsing the disk into a sphere. This is why almost every object in space above a certain size, from planets to moons to stars, forms into a sphere. The so-called edge is not just unobserved, it is physically impossible to maintain. Exploration also exposes the cracks in the edge theory. Humans have sailed across oceans, flown transcontinental routes, and even orbited the Earth. At no point has anyone reached a mysterious edge or crashed into a frozen wall. Commercial flights alone prove the roundness of the globe. When a plane flies from Santiago, Chile to Sydney, Australia, the shortest path arcs over Antarctica, something that makes no sense on a flat disk. If the world had an edge, countless sailors, pilots, and astronauts would have found it by now. Instead, what they've consistently found is continuity, a round Earth with no cliff to tumble from. The flat Earth ice wall claim also struggles with practicality. If such a massive boundary existed, it would be the largest and most remarkable feature on the planet. It would dwarf the Grand Canyon and Mount Everest combined. And yet, no traveler, no satellite, no high-altitude balloon has ever photographed an infinite rim of ice. What we do see, through tens of thousands of images and live feeds, is a curved Earth, blue oceans wrapping continuously around, and Antarctica situated exactly where the globe model predicts. And let's be clear, Antarctica is not a forbidden zone. While it is protected by international treaties limiting development and military activity, scientists, researchers, and even tourists regularly visit. Research stations dot the continent. Cruise ships bring visitors to its icy shores. There is no secret wall guarded by governments to hide the edge of the world. Instead, there is a harsh but fascinating environment that is fully consistent with Earth's spherical geometry. In the end, the edge problem is not just a matter of geography, it is a matter of reality. A flat disk Earth demands an edge, but no such edge has ever been found. Instead, every journey south ends at a continent that matches the globe's predictions perfectly. From physics to exploration, the evidence stacks against the flat Earth narrative. There is no rim, no endless ice barrier, no dramatic plunge into the void. There is only a round planet, spinning steadily in space, with Antarctica exactly where it belongs, at the bottom of the globe. Airplanes and travel. If Earth were flat, global air travel would look completely different from what we know. Routes, distances, flight times, and even the physics of how planes fly would have to be reinvented. Instead, every flight that takes off and lands each day, tens of thousands worldwide, confirms the same truth. Our planet is round. Let's start with flight paths. Airlines choose routes based on the shortest possible distance between 2 points. On a globe, the shortest route is not a straight line on a map, but a curve called a great circle. That's why flights from North America to Asia often arc over the Arctic, seemingly out of the way if you look at a flat map. On a flat Earth, those arcs would make no sense. Passengers would demand to know why their pilot is wasting time and fuel by flying huge detours. But on a globe, the routes are exactly right, and the flight times match perfectly. Circumnavigation drives the point home even further. Pilots and sailors can set off in one direction and eventually return to their starting point without ever turning around. This is possible only on a sphere. On a flat Earth disk, such journeys would force strange reversals or impossible paths. Yet countless circumnavigations, from Magellan's expedition in the 16th century to modern commercial flights, have proven the globe's continuity. Planes depart eastward and return from the west, or vice versa, with no edge encountered along the way. Consider emergencies. There have been cases where flights had to divert suddenly due to medical issues, bad weather, or technical problems. The airports chosen for these diversions always make sense on a globe, even when they look strange on a flat map. For example, flights between North America and Asia sometimes divert to Alaska or Greenland. On a flat Earth, these would appear wildly out of the way. On a globe, they are exactly where they should be, directly along the shortest great circle path. The reality is simple. Air travel only works because Earth is round. The routes, the times, the navigation, and even the safety protocols all align perfectly with a spherical planet. Every ticket booked, every takeoff, and every landing reinforces this truth. A flat Earth could not sustain the global aviation system we depend on, but a round Earth does, every single day, without exception. The sky above. When we look up at the night sky, we're not just stargazing, we're witnessing proof that Earth is round. The patterns above our heads shift predictably depending on where we stand on the planet. On a flat Earth, the sky would appear identical no matter where you were. But reality tells another story, one that has guided sailors, astronomers, and now satellites for centuries. Start with constellations. In the northern hemisphere, the North Star, Polaris, holds steady in the sky, anchoring the direction of true north. But travel south of the equator, and Polaris disappears completely. In its place, the Southern Cross becomes the guide, a constellation invisible to northern observers. If Earth were flat, everyone should see the same sky. Instead, the stars change with latitude, revealing the curvature of our planet. Star trails deepen the case. In the north, if you set up a long exposure camera, the stars circle around Polaris in neat rings. In the south, they circle around a different point entirely, the southern celestial pole. The two patterns face opposite directions, something impossible if we were all on one flat plane. This is not theoretical. It's something any amateur photographer can test, from Alaska to Argentina. And it's not just governments. Hobbyists send weather balloons into the upper atmosphere with GoPro cameras attached. Their footage shows the curve of the horizon, the thin line of atmosphere, and the blackness of space beyond. These aren't billion-dollar operations. They're weekend projects posted online by school groups and enthusiasts. Anyone motivated enough can repeat the experiment, and thousands have. The results are the same every time, a curved horizon stretching into space. In the end, the sky and our own cameras tell the same story. The stars shift as you travel. Constellations disappear and new ones emerge. Star trails spin in opposite circles depending on hemisphere. And eclipses paint round shadows across the moon. Modern photography, from amateur balloons to orbiting satellites, confirms what humans have observed for millennia. The beauty of this truth is that it's accessible. You don't need to be an astronaut or a physicist to see it. You can step outside tonight, point your eyes or your lens upward, and witness the evidence with your own senses. The sky above us is not just decoration, it is proof, eternal and undeniable, that Earth is round. This is AstroTheatis. Stay curious and keep looking up.